Here I have an x-axis with a dot hovering around it. Is there a value of x that's represented by that dot? Or is it because the dot's not on the axis, there's no value that's represented? Well, the dot doesn't actually have to be touching the axis to give a x value. All we have to do is draw a perpendicular to that axis. Perpendicular cuts right across it at 90 degrees here. And whatever that perpendicular touches on the axis, that's the value. So the value of x that's represented by this dot is -3. Check out B, which says what value of x is represented by the dot below, and give your answer. The correct answer is 1. If we trace the dot down, we can see that it intersects at an x of 1, and so that is the x value that's represented here. So when it comes to the x-axis, only the horizontal position, the leftness and rightness, is relevant to x. Up and down is not relevant to x. Now let's take a look at a y-axis, which is not horizontal but vertical. But we still have a positive and negative side to it. What value of y is represented by the point below, if any? To answer this question, we want to trace our dot horizontally to the axis and see where it intersects. It intersects right here at a value of 2, and so that is the value that's represented by that dot. So only the vertical position of the point matters when it comes to y. The leftness and rightness of the point is actually not relevant at all. This brings us to the rectangular coordinate system, which is formed by two perpendicular intersecting number lines x and y. Take a look at the point below. What values of x and y are represented by this point? To solve this, we want to simply trace the point down to where it intersects the x-axis. It intersects at 3, and so that's going to be our x value. And we also want to trace it over horizontally until we touch the y-axis. And then we can get the y value for that point. It's 5. And now what we'd like to do is put them into a coordinate pair, where the x comes first, and then the y. So this point is 3, 5. And that's the coordinate pair form for the point. Now the rectangular coordinate system is divided into 4 quadrants. The quadrants are conventionally labeled as follows. Positive x and positive y is quadrant 1. Positive y and negative x is quadrant 2. When both x and y are negative, that's quadrant 3. And then points which have a positive x but a negative y are located in what's called quadrant 4. So, in which quadrant does the point -5, -2 lie in? Go ahead and answer that. All right, so -5 is the x. negative 2 is the y. So if we want to plot this point on the graph above, we want to go over to a negative 5x and then just trace that up or down. Okay, and then we want to get a y of negative 2, so we want to go here and just see where these two intersect. They intersect right there. And so this is going to be our point negative 5, negative 2. It's clearly in quadrant 3 because both x and y are negative. That's the easy way to tell. Okay, in which quadrant does the point 3, negative 5 lie in? Go ahead and answer that one. Okay, so for this point, we've got a positive x and a negative y. So it can't be in quadrant 1 because in quadrant 1, both x and y are positive. So we actually need quadrant 4 here. We want a positive x and then a negative y. Okay, they intersect right here. And this is going to be the point 3, negative 5. And so that is quadrant 4.